My name is Carly Thornton. I am a math coach in Tri-County. I work primarily at this school, which is called Yarmouth Elementary. This is my 6th or 7th year being a math coach, and my experience is in the classroom as a lower elementary teacher. So partitioning is something I feel really strongly about. I presented about it for a few years at the MTA, like the NSTU presentation day. And it seemed like a thing I might be able to present about online, where I don't need to be able to show you lots of things like in person, although that's really the way I prefer to present, but we'll see what we can do just through using Google Slides today. I do have someone who volunteered to monitor the chat. So if you have questions or want to know something, you can just type it to the chat just at the right of your screen. So I am going to share my screen and we can start talking about partitioning. And if people come, then they're just going to come late. All right. So partitioning. What is partitioning? Well, partitioning is the ability for you or for students to be able to recognize that all of our numbers can be partitioned or broken up into 2 or more smaller numbers. So in most of our outcomes, we're specifically talking about partitioning in 2 ways, but some kids like that challenge of coming up with 3 different parts. But we really need to focus on the fact that it's 2. And we need students to be able to see numbers as those parts that then get put back together. And it's important for students to know that the action of partitioning that number doesn't affect how many it is. So the way that we do that is by doing lots of hands-on things and having students use items, manipulatives, actual people, any sorts of, even like goldfish crackers, to understand that if I have 5 and I break it into 2 groups and I put it back together, I still have 5 crackers. It's not changing what I have. That's probably the most difficult concept for kids to wrap their head around when you first start doing this, because once you take things apart, they start to think that it's different. So they need to understand that 5 or 7 or 13 or 531, when I take it apart and put it back together, it's still the same thing. So this is called part whole thinking, the idea that numbers are broken up and made up of different numbers that are then put back together. So it's important to note that this understanding, we started in primary, but in primary, we're really looking at concrete materials and pictures to make numbers up to 10. And it really starts to make sense to the students when they get to use hands-on kind of things with real life situations. So anytime that you can do that in the classroom, so if it's using the actual students themselves and moving them into different groups, so starting with 5 students and breaking them up into a group of 3 and 2 or 4 and 1, making teams, all those sorts of things are like real life examples of how we partition and break things into their parts. So doing those kind of things really helps students wrap their heads around what that means and why we do it. And for those grade primary kids, often it's that idea of it's the same amount of students, regardless of how we break it up. So if I have 10 students to break into teams, I'm not adding or taking away any more students. It's still those 10. So we really need to work on lots of examples of this so that they understand and they trust that even when I take it apart, it's still going to be the same. So why are we going to partition? Well, a lot of our understanding of numbers and our understanding of the different operations goes back to students' ability to break up those numbers. So if we think of a lot of those mental math strategies that students are going to need to learn in the upper levels, even things like the make 10 strategy in addition, which they have to learn in grade 2. They need to be able to break up a number to make the 10 and then add on the rest. So if they don't understand how to break numbers up to make it work for them, then they aren't going to be able to be successful in a lot of those strategies that they're going to need to do at a later grade. So I've got pictures of 2 different things on the screen. The one on the left with numbers in it, we typically we talk about this as being like number bonds. I have large versions of this that are blank that I've laminated, and that's what I use with students so they can write numbers in it. whereas the one on the right is a part whole mat. Sometimes you'll see the whole on the bottom and the parts on the top, or you can have the whole at the top, the parts at the bottom. There's not really a right or wrong way to do it, and some students prefer it the opposite way with the hole on the bottom. It's one of those things, just like the one on the left there, the number bonds, that kids just can sort of like turn it whichever way makes the most sense to them, so that they are invested in what they're learning and they, can make sense of what it is that they're doing. So that's the what is partitioning and why partition. So when do we partition? So we partition mostly in primary 1-2 is when we have those explicit outcomes that use the word partition. So in primary, we are partitioning numbers into 2 parts up to 10. In grade 1, we're partitioning numbers up to 20. And then in grade 2, we're partitioning numbers up to 100. And then after that, it just sort of falls in the other outcomes, like we're talking about kind of this action, but we don't have it explicitly written out like this. And that partitioning in primary, where they're expected to partition numbers from 2 to 10 in 2 parts concretely and pictorially, that starts in unit 1 of grade primary. So in 3 weeks, those grade primary students are going to start their partitioning already. And in that unit 1, it's quite simple. So it's like show a given number from 2 to 5 as 2 parts with concrete materials or fingers. So you might say, show me 4 fingers. How can I do that on 2 different hands? Or here's 4 bear counters. Let's put them into 2 different caves. Anything that is sort of like acting it out and making it meaningful. And some of this you'll start to see if you are in a grade, which is grade primary or 1, where you have to talk about subitizing. A lot of the things that we do with subitizing, we can also have the same conversations with partitioning. So if we're doing 5 dots and 3 of them are green and 2 of them are red, well, we're partitioning to subitize. So there's a link between those 2 things. That's essentially what it looks like in grade primary. We start with doing it very concretely like that. And a lot of the year continues that same way. We just change the numbers that we're talking about. And then in grade 1, we start to, the outcome talks about doing it in a variety of ways with manipulatives and pictures. So we're talking about like countable items. So it could be, bear counters, 2-sided counters, beads, anything that you can give kids to work with. Those are the kind of things that we should be giving them to partition. Use the actual kids in your classroom, or in the middle of the winter when you've got mittens everywhere. Grab some of the mittens, throw those on a part whole mat. We really want them to use lots and lots of different things. And then in grade 2, the outcome, we go all the way to 100 instead of just 20. And it gives us some more specific examples. So it's talking about using 10 frames. We start using coins. So that is a way that we partition. We're using pictures. So lots of different ways that we do that as the students go through the grades. So you can see how it builds. Where in primary, we're only going to 10. In grade 1, now we're going to 20. And in grade 2, we're going to 100. So really those grade primary teachers, I don't know how many of you are primary teachers, but the rest of us are really going to rely on them to have given them the strong foundation of partitioning. So what does this look like in a classroom? Well, it should be, as I've mentioned numerous times now, kind of like realistic sort of situations. So we do that by giving them story situations. So here's one. There are 9 tulips sprouting up from the garden. Some are yellow and some are red. How many of each color could there be? So I gave students a strip with all of the tulips, and I gave them 9 2-sided counters because those are yellow and red, which matches with my story. So this student took 4 yellows and matched them up with these 4 tulips, and 5 of the red ones and matched them up with these ones. So then when we're sharing, the student can say, well, one of the ways that I figured it out, for some are yellow, I have 4 yellow, and some are red, I have 5 red. I still only have 9 tulips, but I've got 4 and I've got 5. Whereas a different student, I gave them, again, the counters. This student thought that there was going to be more yellow. So this student has 8 yellow and 1 red. Because I said some are yellow and some are red, I wouldn't expect that a student would just give me 9 yellow, because I did say some are red. But there's lots of different ways that they could then work this out. They could have 8 of one and 1 of the other, and then they can switch them around. And there's lots of ways that they can play with this in order to figure out the different options. And my 9 tulips aren't changing. I still only have 9 tulips. The combinations change, but the tulips don't, which is what it's important for them to know. So you could use this as anything. Easter eggs at Easter are a great thing. Like, you can buy the plastic ones at the dollar store. So we could do this way, or we could use it on a part whole mat. I'm in sharing mode, so I can't pull these around, but I've got my 9 tulips, and one part, let's say my left part, is going to be my yellow tulips, and my right bottom part is going to be my red tulips. And so I'm just going to take all of the ones that are in the hole and pull them down into each part. So typically how we would use a part whole mat is I'm just going to come out. We start with them all up in the section that's called whole. So I've got my 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if this is my yellow and this is my red, the students then move whatever they want into each one, instead of then having 9 in my hole and then, like, let's say 3 and 6 down here, then I've got 9 plus 3 plus 6. So just make sure that you're manipulating the actual items that you already have into your part whole. So if we were doing this on the board, I could have this labeled as yellow and labeled as red, or whatever it is that I'm doing, team 1, team 2, Carly's cookies and Corey's cookies, however it is that you want to do it, is fine, as long as we're not adding in to the whole more things than what it is that we're talking about. So that's super important. For the kids to understand that we're not adding or taking away any. And that's, I guess that's the most common error that I see happening with kids, is now then they put 9 up here in the hole again. So hands-on experiences. In order to get students to really develop a deep meaning of partitioning and to get that flexibility of numbers, we want them to be able to experience a lot of different ways of representing numbers. So that's drawing pictures, it's using it in the real world, and those sorts of things. And so knowing that they can break up the number and put it back together is just as important as the rest of the things that we're doing with numbers. So this part whole understanding is so essential for them to be able to develop that number knowledge in their brain and help their math brain grow, and to have an understanding of the different operations as they progress through the different grades. They need, again, to be able to understand that any number that we give them, other than 0 and 1 at this point, can be broken up into the different numbers. So we can do that in things like 10 frames with counters, with number bonds and part whole mats. To the right where I've got the sticks, so 12 can be 6 and 6, 12 can be 10 and 2, 12 can be 8 and 4. That's exactly how it's written in the curriculum. So that's how we want to talk about it with kids. So 6 and 6, 10 and 2, 8 and 4 is the way that we're using our language to speak to the students about partitioning. This is the language for grade primary when it comes to partitioning. So in primary, as you probably, this is from the curriculum. So this is one of the sections, we've got like manipulatives and suggested learning tasks, assessment tasks. So math language is part of our curriculum document. So it's broken down into the teacher language and the student language. And in primary, it's oral language because they don't have to read or write any of the language. And when it comes to partitioning, students are not going to have to necessarily use the word partition. You, as the teacher, are going to use the word partition. You're going to use the word parts and whole, as are the students. You're going to use the term part-whole relationship, but they aren't. They're going to say part-whole. And you see familiar arrangements on there and represent. So there is more to this because like we had just talked briefly about subitizing. So familiar relationships from subitizing comes back in as a link between subitizing and partitioning. And you can see that represented right there in the language. So we know that a lot of the words are similar. If students say the word partition, of course, that's totally fine. It's just not an expectation. So these would be the words that if you're a grade 1 teacher, this is what your primary should come to you already knowing. This is grade 1. So in grade 1, teachers are going to say partition numbers or partition quantities. The students are going to actually use the word partition in grade 1. They're going to say parts or whole and part-whole. Again, only the teacher is using the term part-whole relationships. And they're going to say numeral, represent, 10 frames, number lines. So it is in grade 1, they are starting to use the actual word partition. So that's not like a huge issue if they're doing it in grade primary. And in grade 2, because this outcome encompasses a lot of different things, you're going to see other words here. But here's the words that they need to know. They need to be able to talk about numeral, parts, quantity. Those would be the ones that pertain the most to partitioning. And the teacher is still going to talk about partition numbers, partition quantities. I have no idea why the word partition doesn't show up in grade 2 in the student language if they were already using it in grade 1. That makes no sense to me, but continue to use it with them. You're going to talk about the different parts and partitioning, and there's just lots of other things in there. So this is where they start talking about money. So of course the money words are in there. They learn the word expression, hundreds, chart, number, line, numeral, all those kinds of things. They start tallies in grade 2 under this outcome as well for the first time. So what we typically say is that the number 4 is a great place to start partitioning because we can do it in an even way, like 2 and 2, an equal way. But we can also do it in a way that has more and less. So like 3 and 1. So if you start doing that, the number 4 in grade primary, we can easily do that on our fingers by doing all 4 fingers on one hand and none on the other, or 3 on one hand, 1 on the other, or 2 and 2. So because it's an easy one for them to subitize, count, represent on their fingers, and it gives you several different options, doing it with the number 4 is typically a suggestion of where we start with partitioning and then sort of go on to some of the others. So what can you use to work on partitioning with? Counters and two-sided counters, any kind of counters, bears. I don't know, I've got like trains and airplanes and fruit. Anything that you have that is a counter or not can be used to work on partitioning. Don't give them something that they're just going to play with. That would be kind of a routine that you need to work on when it comes to manipulatives, but you could make it more meaningful to them by giving them, let's say, the fruit. So here's a situation with fruit. Here's your fruit counters. Let's partition them. 10 frames are a great way to partition, especially if you have the like foam ones that you can stick the little pieces into that flip over so you can have some red and some blue. So again, you could have a number even just like 4 in a 10 frame or a 5 frame. Obviously you can use counters in that too and have some of one color, some of another. Sometimes the 10 frame helps students to organize their thinking a little bit more because 10 frames is something and 5 frames is something that they're working on subitizing with. So they can look at the 10 frame and already know that it's 4 things, and then in their brain break it into its parts because they've been working with that 10 frame. Dominoes are another great way. We've already got a number broken into 2 parts. An easy way to work on that from the beginning is give them whichever dominoes you feel are cognitively appropriate or grade level appropriate, and take like a Bristol board or a big shower curtain or something like that and write the numbers. So let's say you have 4, 5, 6, 7, 8, 9, 10, give them a bunch of dominoes and have them sort the dominoes based on what number is represented on it, because it's already broken into 2 parts. A rec and rec is broken into parts, right? We've got the red and the white already. So each row is a part whole already. Some people use the rec and rec and use 2 different rows to represent the numbers, or they can just represent 2 parts and then slide them together. We looked briefly at the part whole mat at the beginning. So I had a part whole mat with the tulips as well. Again, it doesn't matter if it's at the top or at the bottom where we have the hole and where we have the parts, as long as we're moving the things around and have that idea. Coins are another way that we can do part whole. It's something that is, I guess, relatively real life. I don't know how many of our kids are actually using coins at this point, but in theory, it is real life. And those are broken down for us. So, you know, we can have a whole bunch of dimes, and that's our 10s right now. We can use our hands, which we've got that built in to our students already to be able to use their hands, and we're using it for subitizing. You might as well start using it for partitioning at the same time. And using things like dot plates or dots, however you're doing it, is another great way. Speaking of plates, the plates that like little kids use that are divided into 3 sections, which typically have like a big section and then 2 small sections. Those are excellent for doing part whole. Like even if you just go to Dollarama and get the plastic ones, you can write on them with a whiteboard marker, and kids can put their counters or their manipulatives right into the plate. I'm just going to come back over and just share. Yeah. So I don't know if you guys can see, but I've got the hole as the big part, and then the 2 small parts are great. And I've had students just write on them right with a whiteboard again. So those are great. So how do we actually teach them this? Well, we've talked about some ways that we can do it. I'm going to show you some activities that I've done with students. They probably can be changed to any grade level. Most of them are like grade 1, 2. So if you're primary, we'll think about how you can sort of change that for yourself. So this one is sort of a story mat, and I'm going to zoom out. Oh, we might not be able to see it anymore. Let's change what I'm showing. Just going to stop and share again. Okay, hopefully you can see my fish bowls now. So I would have these printed out, and I have some fish counters. So Luke got, and we could have the teacher determine how many goldfish we're working with. We could give children a die and have them roll for how many, or they could choose. So let's say Luke got 5 goldfish for his birthday. How many goldfish could Luke put in each fish bowl? So we're going to solve this by using the actual counters. We're going to put some of Luke's fish in one bowl and some in the other. And some kids could say, well, I can put all 5 fish in one and none in the other. Absolutely. We could then have a conversation of like, is that the most fair way to do it? Do you think the fish would be the happiest this way? What are some other ways we can do it? If you have a split grade level in your classroom, you could have that some students are just using a different number, and that's how students are representing it. So really, when you have it as a blank, it gives you a lot more options. And then I've got sort of like the talking cue for the kids at the bottom. So let's say they broke it into 3 and 2. So 3 and 2 make 5. So I started with 5 fish. I broke it up into 3 and 2, and then here are my fish. So any situational thing like this with a story mat, absolutely you could do. You could have it be with, like, I don't know, tents and kids that are having a camp out. You could have it people at the beach and how many people are, you know, playing in this group versus this group. You can have it as teams. Anything where people need to be split up is what you could do. Bowling is one of my favorite and one of my kids' favorites. So what I do is I have a really big bowling set that I got at Dollarama once, and I set them up. There are, I think, 9 in my set. I have a small one and a big one. So what we start with would be in the hole. So I have 9, and then how many we knock down and how many are still standing are the different parts. You can have them then keep track of, you know, how many we knock down or who's winning. But really the point is to understand some are up, some are down. Those are my 2 parts. I'm not changing how many pins there are by knocking some down. And so that will help to solidify that in their brain. I've got 9, I knocked down 2, 7 are standing, but I still have 9, which is a great way to do it. So in my recording sheet, I just have the students record how many are up and how many are down. I mean, you could have down and up or up and down. It doesn't matter what, as long as everyone's recording it the same way. They do make a game called Skittles that's very similar to bowling, but tiny. So the pins are like smaller than the size of a pencil when you stand them up. I found them at Winners once, and they're just like these, they look like a bowling pin, but they're tiny. And so you can play it in a classroom a lot easier than the big plastic ones. And they're cute and fun. So you could do something like that. I've seen teachers take pop bottles and fill them with cotton balls, or put some cotton balls in them, or water bottles, and stand those up and use those. Less noisy, doesn't take up as much space. And I mean, it's easy to acquire 8 or 10 or 12, however many you want, water bottles to stand up in the corner of your classroom, and then just, you know, get a dollar store ball, or you might have a ball in your classroom. So that's a super easy way to get kids partitioning. All right, eggs in a carton is another one that I've done. And I've done it with the plastic Easter egg. So just, like the week after Easter when they're all on sale, I buy a bunch of those. I use them for a variety of things in my classroom, but this is a great one. So in this scenario, I have one of the large cartons with 18. You could cut up an egg carton. So if you wanted to look like a 10 frame, you could easily use one of the 12s and just cut off the last 2. You could cut it so that it's smaller and it's 6 or it's 5. You could put 2 18s together. It just really depends on what number it is that you need to work with. So in this scenario, I have a carton of 18 eggs. Some eggs are green and some eggs are yellow. How many of each color are there? So I had green and yellow because that happened to be the plastic eggs that I had pulled out to do this with. So they are going to, on here, explain their thinking using pictures, numbers, and words. They could color in on my little grid that's representative of the actual egg carton. They could color that so that they're telling me which ones are green and which ones are yellow. So my question to them was, how many of each color are there? And is there more than one answer? So that's another really important part of this is, when I partition numbers, there's not just one way to do it. There's lots of different ways to do it. And in a lot of cases, there's not a right or wrong way. Sometimes if I'm using partitioning to do something else, like I referenced earlier, the make 10 strategy, if I'm trying to add 9 plus 7 and I want to get to 10, I need to take 1 off the 7 to turn the 9 into a 10. There is a right or wrong way to do that. When I'm filling an egg carton with eggs, I haven't given them any more, prompts. Like I could say there has to be more green than yellow. That would be maybe a way to extend this to make it a little harder for them to figure out. But in a lot of cases, these partitioning and part whole situations, the majority of our students can be successful because there are lots of ways for them to be able to do it. So explain your thinking down here using pictures and numbers and words. They could explain how they know that there's more than one particular scenario that works. Hide and seek is one of my favorites. A lot of us have bear counters. And so for this one, actually, I'm going to go to station cards because I think I have a picture of it. So for bears in a cave, we just need a bowl. So, like paper bowl from the dollar store and some bear counters, and we turn it into a cave. So they're going to roll a die. You can give them 6-sided, 12-sided, 10-sided, whatever numbers your students are working with. And one partner is going to roll the die and they're going to get that many bears. So let's say we end up with 6 bears. One partner is going to put some bears in the cave and some bears out of the cave. And the other student is going to know the whole, but not know how many are in the cave. So if we have 6, I put 2 in the cave and you see 4, you have to then try to figure out that there's 2 bears hiding in the cave. So you could model this easily with your class multiple times and then turn this like into a station or however it is that your students work on it. For me, I had students doing it, acting it out. So they had 12 as their whole. So they then broke it up. Well, I see 4. So whatever the answer is, how many are ever in the cave must be what's left over and is going to be the other part. So, and then our number bond, we've got the number of bears in the cave and bears outside of the cave. I don't actually know if bears hibernate together, but it's cute. So that one's called Bears in a Cave. I am just going to scroll up so you can see these station cards. And at the very end of my presentation, I do have my GNSPES email for you guys, so that if you actually want me to like share you any of these things, I will gladly do that so that you can have them. So this is exactly what I just told you about the eggs in a carton. So ways to differentiate, just change how many eggs we have or use 3 colors instead of 2. Bowling, here's the station card that explains kind of how we do bowling, the way that we can differentiate it. And again, we can progress into using an addition or subtraction equation. Bears in a cave. Number bracelets are something that I've seen other teachers do. I've never myself done it with students, but you just need like a pipe cleaner and some beads, and you're going to make your own combination. So we're going to put 3 on. And so I can have 0 and 3. I can have 1 and 2, 2 and 1, or 3 and 0. So here's all the different part whole combinations for the number 3. So you could just have a variety of different numbers with the digit on it and that number of beads. And students are just experimenting with how many go on one side and how many go on the other. Target toss is another fun one to do. You can do it in a loud way. You can do it in a quiet way. It might be something that you want to do outside, or if the gym is empty, be able to do it in there. So this, use a hula hoop or use some of the sorting circles that you probably have a whole bunch of in your like closet with all your manipulatives. And students are going to take a handful of bean bags or 2-sided counters, whatever you want, and throw them at your sorting circle, target, hula hoop. And they're simply going to do part whole. So the total number of items that they threw, how many are outside of the hoop, how many are inside of the hoop. I'm not changing how many things I throw. I threw 5 things. 4 went inside the hoop, 1 is outside the hoop. That's still 5. So that's kind of like a hands-on way to get students practicing and having, a little bit of fun at the same time. And fish bowls we talked about with Luke getting fish for his birthday. We could easily differentiate that by just changing the die that the kids are using. So that's some of the stations. And again, I will give you my email in a few minutes when we finish. I do have a game called I Wish I Had. And I like this, and I've done it with some kids, and they like it. And yeah, let's go through it. So the way that this game works is I'm going to show you a 10 frame, and I'm going to tell you the number I wish I had. So if I show you 4 and I wish I had 10, your answer is going to be 6. So you could do this with students showing you the answers like with fingers. They could write it on a whiteboard, whatever's going to make the most sense for your classroom. So I'm going to show you what that looks like. So here's what I have. I wish I had 10. So depending on how, what grade level you have, how many times you've done this, the amount of think time that you're going to need to give to students is different. And also depending on what the number is. Hopefully, I wish I had 10 when you're looking at the number 5 would be easy for students to figure out. So I might say, okay, 3, 2, 1, show me your answers. If it's on their fingers, so they're going to hold up 5. There's our part whole. I have 5. If I have 5 more, then I have 10. All right, here's what I have this time. I wish I had 10. And it's a great time to be able to have a conversation of how did you figure out that you needed 7 in order to get 10? Some students are going to say they count every single box. Some are going to say, well, I need 2 more to have 5, and then 5 more is 10. Or maybe they're going to see all 5 empty ones at the bottom and then 2 more. It will give you a lot of insight into what they are thinking when you have those discussions instead of just moving on. Like maybe you get through 3 of these in a day. You don't necessarily have to go into this thinking, oh, I'm going to do like 20 of these slides. It's that conversation that you can have with the kids and them learning from the other students. That's what's most important. So here I've got a whole row of 5, but I wish I had 9. So kids might say, well, if I had 5 more, I would have 10. So 1 less than that is 4. I wish I had 8. I wish I had 13. So at this point, I've gone on to 2 10 frames. So students obviously just need 1 more to get to 13. But even having the conversation about how do you know what number I have and what I need to have 13, great conversations to be able to have. I wish I had 10. I wish I had 20. So now I'm going to fill 2 10 frames. So what do I need in order to fill it? You can see that you could easily do this with a 5 frame, a 10 frame, the double 10 frame like what I have. It progresses easily. And this would be a good thing to do. You know, sometimes you have like a few minutes when the kids have come in from recess and they have phys ed in 10 minutes, but you don't know what to do with them. This would be one of those kinds of quick sort of activities where they're engaging their brain. You're having a conversation. It's not super difficult. Most kids should be able to participate, but gives you something meaningful to do. So in this one, the cognitive level of difficulty here has gotten a little stronger because we have to cross 10 frames. So we have to fill 1 and start the next one. So I did say I wish I had 20 before, which seems like it would be more difficult, but I was already filling that second 10 frame. I think I had 18 in that other one. Whereas now I've got to fill 1 and then have 2 more again after that. So they're having to work a little harder to get to their answer. So that's called I Wish I Had. Oh, I see a notification. I don't know what that means. Okay, I'm going to go back over here. So those are the things that I want to talk about partitioning. This is my email. I would gladly answer whatever questions you guys have. So it's just carlythornton@gnespez.ca.